Alright, section 1.3. By now we should know what an expression is. It could be anything. I could take 18 times x plus 4 times 3 plus r, divide all that by 7, add a 6, whatever. That's an expression because it uses any combination of numbers and variables and operators. Operators like plus and multiply and divide. Could use some subtraction in there. But that's an expression. But this is just completely random. What does x represent? What does r represent? What would it mean to plug in numbers for x and r and find the result? I don't know. I don't know if this has any significance to any real life situation. But certainly we could write an expression that does have real life significance. And a most basic one would be something like the product of 7 and another number. Well, we don't know what that another number is, so let's just call it x, another number x. So 7 times x, we could write times x, or we could write 7 times x. We could confusingly write 7 times x. That one's out. I don't like that one. Or we could just write 7 next to the variable x. When you write them right next to each other, that's understood to be multiplication. So we just need to know what numbers and what variables are involved and how they're interacting with each other. So we might use addition. Okay. Where they might tell us to add two numbers, find the sum of two numbers, say a number increased a certain amount, stuff like that. Stuff that would mean that we are making a number bigger. Taking one number and adding it to another. We could do subtraction. We could find the difference. We could just say minus. We could say less, less than, decreased. Okay. Something that the situation is communicating. One thing has become less than it was to start with. That would be subtraction. Multiplication we could say times, or we could say find the product, or we could just say multiplied by, or something like that. Division might be the quotient, or just divide by, or divided into, or anything like that. Something that's telling us that one quantity is being divided, or evenly distributed between some other quantity. So there's a real life expression that I use a lot, and it has like an x in it, and I replace the x with a certain real life quantity. And that expression is used when I grade tests and even quizzes, which for me in my class I score a test or a quiz as a percentage. And we should know how to find percentages. If you're a little rusty, it goes like this. You have, if you have a certain number right out of the total possible points, your percentage would be how many you got right out of how many are completely in total possible, right? So you take the part that you got right divided by the whole thing, and you'll get a number between 0 and 1, and you'll take that and you can multiply it by 100, right? And that would be a percentage. This will give you a decimal between 0 and 1. You multiply that by 100, and that'll give you something between 0 and 100. So the thing that I do when I grade tests is I just go through the whole thing and mark stuff wrong and take points off. you might lose a point or a half a point or something like that. Then I add all those parts that you missed. That's the incorrect parts, and I take it away from the total, and that will tell me how many you got right, because the total minus the number you got wrong is the number you got right, and then divide by how many you could possibly get right. So here is an example of that. So to calculate your test score, which is going to be a percentage, take the difference of the maximum score, so maximum possible score, and the number of points missed, the numbers that you got wrong, and divide the difference, that difference that we just talked about, by the maximum score. Okay, and then we might actually want to say, and multiply by 100. Okay, so let's write out that expression, and actually, well, I'll show you what I do with it afterwards. So take the number, the total score possible. So maybe the maximum score we could call M. Okay. So take the difference of the maximum score and the number of points missed. So maximum score minus, say, the number you got wrong. Okay, so that's the difference that they're asking for. Take that difference, divide the difference by the maximum score. So we're going to divide this difference by the maximum score, okay, and multiply by 100. So we're going to multiply that by 100. Okay, so I would take this and I would put it into my calculator, and let me show you what that would look like. So I take out my calculator, I go into this thing, it's y equals, so y is the output. It's what you get when you plug in all the numbers that you would need to know. So y is the output, y would be your percentage, it would be your score. And all I need to tell the calculator is all this stuff. I can have one variable in there, right? And so as I'm grading tests, the thing that is a variable is, from student to student, is how many points they'll miss. But everyone will have the same possible maximum score. So for an example, let's say that the max score is 25 points. Okay, so let's bring this back up. So the maximum score is 25 points. So these m's will be 25. So let's see, I want this numerator to be grouped together and then divided by m, right? So I'll group them together with parentheses. 25 minus, well, that's the variable, how many points you miss. Okay, I want to divide that by the maximum score, so that'd be 25. Okay, but the number that you get right divided by 25, that's going to give a number between 0 and 1. 0 for you got nothing right, meaning you missed all 25. Or 1 for missing nothing and getting 25 divided by 25, which is 1. But to look at it as a percentage, we're going to multiply this by 100. Okay? So if we want to multiply this whole thing, we're going to group it together and multiply it by 100. So we will press this second button, and this INS stands for insert. We're going to insert a parentheses, open parentheses, and then after the whole thing we're going to enter a close parentheses. Then we're going to multiply the whole thing by 100. Okay? So the result of an expression like this is just going to be a percentage, 50%, 75%, 100%. So in order to enter values in for x, I can hit second table. Let's just, there we go. I can just delete all these. Okay, so let's say somebody missed all 25. That means that you get 25, the maximum score in our example, minus 25, which is 0, divided by 25. Doesn't matter that we're divided by 25. 0 divided by 25 is going to be 0. 0 times 100 would be 0. So if you missed all 25, you get 0. Okay. let's say you missed 12 and a half. Well, that's exactly half of 25. So we should get a 50%, which we do. Let's say we miss just 5. Okay, that's an 80%. If we miss none, then we should get 100%. Okay, so see, this is the kind of this is an expression that I use all the time. Every time I'm grading tests and quizzes, I get my calculator out, I put in an expression just like this, and it calculates your score for me so that I don't have to press the same sequence of buttons over and over and over. All I need to do is put in what the number you missed is. So that's basically what we're going to be doing. We're going to just be taking words and turning them into algebraic expressions that we could then plug different values into and find out the result. Alright, so another idea, really kind of the last idea in this section, would be that of a rate. Okay, rate is a word that I'm sure you're familiar with, the rate at which something is happening, the rate at which something is changing. One rate that we're familiar with would be miles per hour. Right? They're posted all over the roads that we travel on. Now, you won't see a sign like this. You won't see speed limit 400 miles in 8 hours. Right? They tell you how many miles you can go in 1 hour. If you were to have gone 400 miles in 8 hours, how many miles did you go in 1 hour? How fast were you going, at least on average? Well, we want to know how many miles per 1 hour. So, well, we want 1 hour down here, so if you divide 8 by 8, you get 1. Right? So the result here is going to have a 1 down here. It's going to be 1 hour left after you divide 8 by 8. But you can't just take this fraction, divide the denominator only by 8, and expect that you're going to have the same value. So in a fraction, whatever you do to the denominator, you have to do to the numerator if you want it to stay the same. If you want it to stay equivalent to what it started as. So if we divide the denominator by 8, we need to divide the numerator by 8. So 400 divided by 8 is 50. So if you go 400 miles in 8 hours, you've gone 50 miles in 1 hour, at least on average. So if you knew that and you knew that none of the signs ever said anything less than 50, you never went over the speed limit. But I certainly wouldn't want to drive 400 miles at 50 miles an hour. That would be a nightmare. Anyway, that there is what we call the unit rate. Okay, a unit is just a 1. It's just one of whatever we're talking about, and here we have 1 hour. The unit rate is how many of these per one of these. Okay, so if you're still on a cell phone bill where you use lots of minutes and you pay for the number of minutes that you go over, if you used 60 minutes and that cost you, let's see, we want to go the other way. If you talked for 60 minutes and that cost you $5, okay, what we want to know is we paid $5 for 60 minutes, but how much did we pay for just one of those minutes? So in the denominator, we're going to want to divide by 60. So 60 divided by 60. We're also going to need to take 5 and divide it by 60. Right? Use the same notation in both places. Alright, so 5 divided by 60. Ooh, I definitely don't know that decimal off the top of my head, so come back to the calculator here. 5 divided by 60, 0.083. So 0.083 what dollars? per 1 minute. So that would be 8.3 cents per minute, which for overage minutes is not too bad. But that's the unit rate. That's how many dollars, how many cents were we paying for every minute that we go over. Alright, so we divide the numerator and denominator by the denominator. Whatever's in the denominator, we divide both by that, and in the denominator we'll get the unit of whatever we're talking about, minutes or hours or feet or whatever. And in the numerator we'll find out how many of these we have per one of these. Okay, which is useful if we know. Let's say it's good for comparing. What's the best deal at the store? If you go to the store and you see 2 boxes of cereal, and one is 36 ounces, and you look at the price tag underneath, and it says $4.68. And this one is a 24-ounce box, but its little tag, it's got a little starburst on it, and it says there's a sale, and that's happy. And it says that this box is only $3.60. Well, certainly this is less money, but if you tend to buy this box of cereal over and over and over, like Choco Flakes or something, and you buy it all the time, you want to pay less, per flake, or really per ounce. If you're just trying this out and you don't know if you're ever going to buy the cereal again, you might want to just pay less money one time, but if you buy it a lot, you want to pay less in the long run. So we want to know which is cheaper overall, right? And so we have to have something that we can compare between the two that's equivalent. To say that this costs $3.60 for 24 ounces and this costs $4.68 for 36 ounces, there's nothing to compare there. So we need to take it down to the unit price, right? We'll divide this up into 36 little pieces and see what one of those ounces costs and what one of these ounces costs, and see what's a better deal. Or you might do it. My wife and I buy diapers all the time. Sometimes, most of the time we'll get the big box, and sometimes the little box will be on sale, and we'll compare and see, how much does one diaper cost in the smaller box. And if it costs less than one diaper in the big box, we'll buy the small box. So this one, you are going to pay $4.68 for 36 ounces. So we're going to divide this by 36. Divide by 36. We're going to divide this by 36. And get out the calculator. We know 36 divided by 36 is 1, so 1 ounce down here. But in the numerator, we take 468 divided by 36, and we're paying 13 cents an ounce. Okay, that doesn't really tell us much. We need to compare it to something equivalent over here. So 360 divided by 24. Okay, so divide both by the denominator. 360 divided by 24. And we're paying 15 cents per ounce. Okay, and that'll happen a lot. Most of the time when I compare the sale price to the bigger box, the bigger box is typically still cheaper. And in general, buying a bigger box of the same thing is cheaper because it costs the company less to put it in a big box rather than making a bunch of smaller boxes, and so on and so on. So there you go. There's an example of a rate. When we use rates in real life, when we use unit rates, we're comparing prices, or we're comparing miles per gallon, or we're comparing dollars per diaper, or whatever the example is. So we'll do more specific examples from the homework problems in the next video. Thanks for watching.